Welcome back to the PGCET 2025 MCA preparation series. In the previous video, we solved some important questions from the computer science section and discussed the concept behind them in detail. In this video, we will continue solving more previous year question paper problems, focusing on important topics that are frequently asked in PGCET. I'll explain each question step by step so that you can clearly understand the approach, logic, and shortcuts to solve them quickly in the exam. Make sure to watch the video till the end because I will also share some useful tips and common mistakes to avoid while solving these questions. Let's get started with the next set of questions. In previous video, we are completed up to this slide. The next question is, with respect to binary, octal and hexadecimal number system, S1, octal and hexadecimal representation offer compact representation than binary. And statement 2, binary numbers are fundamental in computing and are used at the lowest level in digital system. So first of all, here we have a statement S1. Octal, hexadecimal, decimal, binary, all these are belongs to the number system. Binary, it will allow only two digits, 0 as well as 1. And decimal, it will be allowing from 0 to 9. And octal, it will allows the numbers from 0 to 7. Hexadecimal, it will allows from 0 to 15. 0 to 9 decimal value, and after that 10, 11, 12, 13, 14, 15 are represented with the A, B, C, D, E, F. So when we are representing any of the decimal number in the binary, combinations of ones and zeros are more here because only the base value it is 2. We are dividing the number by 2 and will go on collecting the remainder. Obviously, number of digits collected will be more here. And at the same time, if we have a decimal number that we need to convert into the octal, that octal, it will be having the digits 0 to 7 here. So here we are dividing the number by 8 and we'll go on collecting the remainder. Obviously, here the number of divisions will be less. And like that, we have a hexadecimal. In hexadecimal also the same thing. The given decimal number is divided by the hexadecimal and we'll go on collecting the remainder from bottom to top. So here still the number of divisions are very less comparing to that of the octal here. So here we have a binary number of digits combination, it will be more. Next to that we have a octal and next to that we have a hexadecimal. So octal and hexadecimal representation offer compact representation than binary. So here to illustrate the same concept, we have an example. Now the number, binary number, it is a combination of 8 ones. And this one will convert into the decimal. When we'll be converting this one to the decimal, that decimal value, it is divided by 8. Decimal value, it will be divided by 8. Then we'll get this octal value, 377. And the same decimal value, when we are dividing with the 16 hexadecimal, we'll get the combination of FF. Here we can compare that combinations for the same decimal number, combinations of 1, it will be 8. And combinations of the digits in octal, it will be 3 digits. And hexadecimal, it is of the 2 digit. That's why octal and hexadecimal are compact in representation than that of the binary. The question is how, what is the decimal number for this and how that decimal number will be converted into the binary, octal as well as hexadecimal and vice versa. Like that, what is the number system and what are the base values and what are the restrictions to be given for the numbers and how the conversion of one number system to other number system. Related to this, we can go for the discussion in separate video itself because the number system is very, very important with respect to the PGCET exam. Minimum 4 to 5 questions are based on the number system itself. S1, it is the correct here. We have to move to the S2. Binary numbers are fundamental in computing and are used at the lowest level in digital system. So binary, that system language itself, computer language, it is a binary, 0 and 1. Computer can understand only the binary digits here, which is a fundamental in computing. In the hardware level of the system, that is the lowest level of the system, memory, where the data it will be storing in terms of the binary digits. So binary numbers are fundamental in computing and are used at the lowest level in digital system. Always the storage of the data in terms of binary digits. That's what here we have a correct statement is both S1 as well as S2. Option 1. The next question is the negative numbers are stored in 2's complement form. Then range of numbers that can be stored in 8 bits is negative numbers are stored in 2's complement form, that is of the 8 bit. Numbers that can be stored 8 bit. 8 bit in the sense 0 to 7. Here we have a 0 to 7 positive values and 0 to minus 7 negative values. It is given negative numbers are stored in 2's complement form. Then range of numbers that can be stored in 8 bits is n equals to 8 it is given. The formula of n bit 2's complement is minus 2 raised to n minus 1 to plus 2 raised to n minus 1 minus 1. So here we have a positive values as well as negative. The totally 8 bits. 8 bits value means it will be taking from 0 to 7 here. 0 to 7. This is of 8 bit. And like that only 0 to minus 7 negative values. Here we have a 0 to minus 7 negative values it will take. Why it is up to 7 means 0 also it is counted here. 0 for the negative also it is counted and 0 it is counted for the positive also. That's what here we have a negative values 2 raised to n minus 1 where n equals to 8 it is given. 8 minus 1 means minus 2 raised to 7, that is minus 2 raised to 7. And positive values 2 raised to n minus 1. That is plus 2 raised to n minus 1. That is the 2 raised to 7. And here in case of the positive range, minus 1 it is given. Why it is given means here we have a sign. That sign it will takes negative sign it will be taking the bit 1 and positive sign it will be represented with the bit 0. So when it is a negative value, one extra bit it is required to represent the negative. That is the binary 1. That's what here we have a 1 value. It is more than that of the positive. 0 it is ignored here. No extra bit it is required to represent positive value. That's what to avoid that extra bit it is given 2 raised to n minus 1 minus 1 here. So here we have a given n value 8. We'll substitute 8 here. That is minus 2 raised to 7 to plus 2 raised to 7 minus 1. So this 2 raised to 7 will be converting into the decimal number, exponential to that of the decimal number, integer value. That is minus 128 to plus 128 minus 1. That is 127. So the answer will be minus 128 to plus 127 it is. So this is how we'll be representing 8 bits, 2's complement. Like that only, suppose now we have a 4 bits. We have to take 0 to minus 3 and 0 to plus 3. 2 raised to minus 2 raised to 3 and 2 raised to 3 minus 1. The answer will be minus 128 to plus 127. The next question is, "53 in 2's complement form is now it is a positive value. 2's complement simply it is nothing but conversion of this decimal number to the binary number. Directly we have to consider that one and prefix with the 0. How to implement this one for both positive as well as negative values here. Now, initially here we have a positive numbers. In 2's complement, positive numbers are represented in the same way as their binary equivalents. Means just we are converting this decimal number to the equivalent binary number. That itself it is a 2's complement. Now the decimal number given it is 53 and its complement value it will be 0110101, which is nothing but a conversion of this decimal to directly binary here. Nothing else to be done. In an 8-bit arbitrary format. 8-bit arbitrary format. So whatever the numbers we are getting, we'll be prefixing with the one extra zero. The most significant bit is 0, indicating that it is a positive number. Always in number system, that positive sign, it will be indicated with the 0 and negative, it will be 1 here. Then negative numbers. Now the answer for this question, given that positive value only 53, that's what the 2's complement of 53 is nothing but this combination, which is the option 3. So the correct answer for this one is the option 3 here. And negative numbers. Suppose now it is given minus 53. To find the 2's complement of negative number, here we have a first step what we have to do. Minus 53, just we'll consider 53 and we'll be converting to the binary value. That is, first step is nothing but a conversion of decimal number to the respective binary. Then this 53 minus 53 it is, that's what we have to complement this number. So whatever the binary conversion we are getting, that will be complemented in the invert of the bits. That is, change all the zeros to ones and ones to 0. The complement of this number is this. Wherever there is a 1 replaced with a 0, wherever there is a 0 replaced with a 1. And after by complementing this binary number, we should add 1 to the inverted binary number. That is, we should add 1 to this one. That is, this entire whole complemented number plus we'll be adding 1 for that. So just for convenience, we have taken some zeros. We'll be adding 1 here. That after by adding the result, what it will comes, that it is the 2's complement of minus 53. If the number is given minus 53, that answer should be this one here. This it used to come. So now it is given the positive value. That's what only the complement, binary conversion of this decimal itself, it is a 2's complement. Correct answer is 3 here. And the next question is, select the correct arrangement in the decreasing order of size. So memory size calculation, it is very, very important here. In this, we have a memory, how it is calculated, the basic unit, the smallest unit of the memory, it is 1 cell. That will be considered as a 1 bit. So 1 bit, it is a minimum allocation. In that 1 bit, either will be storing the value 1 or 0. That's what in each cell we have a 2 possibilities. That's what in binary base value it will be taken 2. 2 raised to 0, 2 raised to 1, 2 raised to 2 and all. Memory will be calculated in the exponential form of the base value 2. So here we have a 4 bits, it is called as a 1 nibble. Like that only 1 cell it is a 1 bit. Combinations of 4 cells, that is a 4 bits allocation and it will be considered as a 1 nibble here. And combination of 8 bits it is a 1 byte. And like that we have a 1024 bytes, 1 kilobyte, kilobyte to megabyte, megabyte to gigabyte and terabyte and petabyte. Like that we have a in series, all the memory values it will be calculated here. The same question, it has been asked previously, but it was in the different format. I'll show you. Already we had solved in the previous. Look here. What is the question it is given? The match the following it is given. But the same concept it is. Now the same question it is asked in the different form. That is to arrange in the decreasing order of the memory size here. So decreasing order means highest memory, how much it is? Gigabyte. And from gigabyte itself it is started. Gigabyte, after that we have a megabyte, after that kilobyte, and after that we have a byte here, and after that nibble, and then bit. So GB, MB, KB, byte, nibble, and bit. The correct option for this one is 3. So next question is, given the following list. So here we have some input devices, memory devices, system software, and operating system. First of all, before comparing with the list 2, what is the input device here? Through which we are feeding some information to the system. We'll be giving some information to the computer system, that is called as a input. Through which devices we are feeding the information. We are giving instruction to the computer, input devices. And memory devices means that where we can store the data in terms of binary digits, zeros as well as ones. And system software. System software is nothing but the software is the collection of programs, and these programs are written for the particular aspect of the hardware part of the system here, or else the particular part of the system, that is called as a system software, which is dedicated for the particular task. It cannot be applied in the different field. Next one, we have a operating system. Operating system is nothing but one of the system software itself. And operating system is the collection of all the system softwares, which will make the entire computer system to work here. That hardware, it will make the hardware to work in terms of the software guidance here. So operating system, it is one of the system program, collection of the system programs it is. So here we have a input devices. Input devices, which are the input devices? Keyboard or standard input device, and monitor, it is a standard output device. Keyboard, microphone and all. The sum of the other input devices are the mouse, scanner, microphone, webcam, everything are comes under the input devices. Memory devices, where we can store the data. Here we have a floppy disk as well as hard disk. Along with this, we have a latest SSD and pen drive. And next one, system software. System software means the compiler, assembler. Compiler, it is one of the system program which can convert the high level language to the respective machine level language. And assembler, it will be converting the assembly language to the respective machine level language. And these are dedicated only for these tasks. These cannot be applied in the different fields. And operating system, Windows, Linux, Unix, and here we have some other operating systems, Mac OS, Android, iOS, all these are the operating systems. Operating system is nothing but a system software. It is a collection of the programs, collection of the softwares. After by installing the operating system only, we can work with the computer system. Until to install the operating system, the computer is just an electronic device. After by installing the operating system, it will start acting like a computer system. So the correct answer for this one is 3. A2 input devices and B1 it is memory device, and C4 compiler and all. D it will be of Windows, Linux and all. 3 it is. So the correct option is 3. Let us move to the next question. The A memory is used to be the performance mismatch between C memory and the D. C memory and the D. So here it is given alphabets A, B, C, D. In this position, you have to insert the suitable words by selecting from these options. Here we have a different components of memory and resistors and all different components of the storage and efficiency that we have to fill here. So the A memory is used to be. A memory is used to be means here we have a type of the memory is used to increase or decrease the performance of mismatch between the cache memory, main memory as well as the CPU register. So here we can go for the option 3. Here we have the cache memory is used to decrease the performance mismatch between main and CPU registers. So here we have cache. It is one of the main memory part, which is very near to that of the execution area. That is where the CPU it will be performing the particular task. Adjacent to that we have a cache memory. That usually what we'll say cache memory, it will be exist between the main memory as well as CPU. And this one, every time, rather translating the data executed, partially executed data to the main, it will be storing in the cache. Cache main objective of the cache memory is to increase the performance speed. It will be increasing the efficiency of the execution. And here we have a decrease. The memory is used to decrease the performance mismatch. Means here what happens? The main memory, it will be very slow, and CPU register, it is very fast here. And when it is executing the data, if any data it is required to bring from main memory to that of the CPU register, that execution area, critical section area, it takes a lot of time. So there is a gap of the speed between the main memory as well as CPU registers. This gap, it will be filling with the cache. The cache, it will be existed as an interface between the CPU registers as well as main memory. The cache, first we have a main memory, and after that we have a cache, it will comes, and after that CPU register. So cache, it is very much near to that of the CPU register. It will be avoiding the gap of the speed between main as well as CPU register. That's what the option 3, it is the correct. The cache memory is used to reduce the speed gap between the main memory as well as CPU registers. The next option is identify the correct answer from the given options. Mouse is a device which can be connected externally to the computer. Obviously, we'll be having connection with the CPU. Once it is connected, that it will starts giving the service, and disconnected means no service. External device which is connected to the system. Left and right buttons of the mouse have the same functionality. No, left mouse button is having the different functionality than that of the right mouse button. Both are having the different functionalities. That's what the second option, it is wrong here. First option, it is correct. Third one, moving speed of the pointer on the screen is fixed. It is not fixed. It will be varied here. Moving speed of the pointer, it is controlled by the mouse movement. In which direction will be moving the mouse, the electrical signals will make the pointer to take in that direction itself. That's what, it is not a fixed one. It is not a static here. So the option A, it is the true, correct. And B and C are the wrong. Here we have a is true and B and C are the false here. The mouse is handheld pointing device used to control a computer's graphical user interface by controlling movement of the pointer on the screen. The pointer is controlled by the mouse. It typically includes a left button for clicking, and selecting items, and right button for additional functions like right clicking, which opens a menu and all. So both are having the different functionalities. Next option is consider the following statements with respect to internet. A computer requires a correct IP address to access the internet. Internet is a worldwide system of interconnected computer networks and electronic devices that communicate with each other using an established set of protocols. So here in statement 1, computer requires correct IP address. IP means Internet Protocol Address to access the internet. So this is very genuine, which it will give the unique identity of your system in the network. Yeah. That should be existed. This is true. Yes, true. Internet is a worldwide system of interconnected computer networks and electronic devices that communicate with each other using an established set of protocols. Protocols are very important here. Once your system, it will be installed with a set of protocols. Protocols are nothing but rules and regulations which are following the connectivity between the different systems. So once the protocols are existed, then only it is possible to connect with the network here. That is S2 also it is correct. S3, one of the biggest advantage of internet is a safe cyberspace. No, this option it is wrong, because in network there is always a problem with the security. One of the biggest advantage that here we have a internet is not completely safe. There are a risk like hacking, malware, phishing, etc. So it is not a safe one. But IP address, every device on the internet must have an IP address. It helps in identification and communication between the devices. And next one, we have a interconnected worldwide system, interconnected networks using the protocol. This is the correct definition of the internet. Devices communicate using the protocols like TCP/IP. TCP, transfer control protocol, and IP, internet protocol. Both are a very required options. Both are exhibiting the different protocols in order to connect the multiple systems here. So the correct option for this one is S1 and S2 are true, but S3 it will be false. Rest of the questions will continue in the further video. Thank you for watching. Till then, see you.